Good morning, students. Students, in this video lecture, we would solve the numerical problem which you are seeing in the blackboard. The first numerical problem is a body falls from the top of a building and reaches the ground 2.5 seconds later. How high is the building? Take g small g equal to 10 meter second minus 2. So we have to solve this numerical problem first. Answer first. First of all, we would understand this problem, then we would start solving that problem. So suppose this is a building and this is ground. This is ground and this is top of the building. A body falls from the top of the building. So this is top of building. This is the top of the building. Okay, and reaches the ground 2.5 seconds later. A body is dropped from here. A body falls. It is coming towards ground. You have to understand that when we draw an object from a certain height, suppose this is h, height of the building. This is the h. This is height of the building, and we have drawn this object, this body from h height, which is top of the building. So at the point here, top, suppose this is A point and this is ground, this is B point. At the point A, which is at the top of the building, what is the velocity of the body? Actually, we have just dropped at that point. It means at that point, body is at rest. When we dropped it, its velocity continuously started increasing because of the gravitational force of the earth. So the object started increasing its velocity, and as at the time, at the instant it touches the ground, at that point the velocity attained by the object would be maximum. And in between initial and final position, the body is accelerating because of the gravitational pull of the earth. So this problem we would solve by the equations of motion for the constant or uniform acceleration. And as I told you in the previous video lecture that we would use these equations. First equation was u equal to u plus at. But as I told you, here in this type of motion which is affected by which is because of the acceleration due to gravity, which is because of the gravity of the earth, we replace this small a, which is acceleration in the linear motion, by the letter small g, acceleration due to gravity. Similarly, s is equal to ut plus half in place of a gt square, and the third equation v square equal to u square plus 2gh. These equations are useful for solving these problems. Okay, so here the initial velocity u is 0. The velocity at this point is 0. What is the height? We don't know. We have given only the time, which is 2.5 seconds. So the time t equal to 2.5 seconds, and we have to find this height h. In place of s, distance, in linear motion case, we would replace this by h, height. H equal to ut plus half gt square. So this equation would be useful for this problem. You are seeing here, we have not given we have not given final velocity at this point. We don't know the final velocity at that point. So we would use this equation because u is 0, this term would be 0. We have known g value, which is 10, and we have given t. So we can find h by this second equation. So just put these values in the second equation. So what we get, h equal to half, only half gt square term would be remain. So half g is 10, and what is t? This is 2.5. This is 2.5 square, and it would be 2 into this is 5. 25 square 625, and after 2 decimal 6.25 into 5. Just multiply. 25 5 is 125. So 125, 25, 31. So it is 31.25, and SI system it is meter. So this is the formula, this is the solution of this first numerical problem. I think you got my point here. Now we would solve You are clear this problem? In this type of problem, as I told you, there is a acceleration due to gravity, and at the top when we just left the object, velocity is 0, and as it coming down towards the earth, its velocity continuously is increasing, and at the instant at just reaches at the ground, at that instant the velocity is maximum and the object is accelerating due to gravity. So these equations would be useful for solving this problem, and according to our information given in the problem, we would use the second equation. You are seeing we have already u equal to 0 and time, other information are not given, so the second equation is useful, and we have find that what is the height of the covered bridge is 31.25. Now the second problem. What the second problem? The second problem you are seeing that the mass of a planet is 10 to the power 18 kg and its radius is 10 to the power 3 meter. So we have given answer second. We have given mass of the planet MP. It is 10 to the power 18 kg and its radius of the planet 10 to the power 3 meter. Calculate the acceleration due to gravity on its surface. We have to find g of the planet on its surface. So for finding g of the planet, use the known value of g. What is the value of capital G? It is 6.67 into 10 to the power minus 11. So the relation of g and g is capital G equal to g m p upon r p square. This is the relation between small g and capital G. You can see this relation in the previous video lecture. So just put the value and solve this. What is the capital G? This is 6.67 10 to the power minus 11 into what is the mass? It is 10 to the power 18. And what about RP? It is 10 to the power 3 and 10 to the power 3 square. So finally, what is the G? P equal to 6.67 into, this is 10 to the power 3 to the power 2, it is 10 to the power 6, and 10 to the power 6 in numerator becomes 10 to the power minus 6. Minus 6 and minus 11, minus 17, minus 17 and 10 to the power 18, it is 10. So it would be 66.7. GP 66.7 meter second minus 2. So this is our final answer, 66.7. I think